Welcome. Let's take a look at finding the derivative of some hyperbolic functions. Our first derivative we want to look at is what is the derivative of f of x equals 3 sinh of x. And below we have a table that contains the hyperbolic functions and their corresponding derivatives. But before we get started on finding the derivative of 3 sinh of x, let's go ahead and convince ourselves that the derivative of the sinh function is in fact the Cosh function. So let's get started by taking our sinh function and writing it in its exponential form. So that would be e to the x minus e to the negative x divided by 2. Now, with the sinh function written in its exponential form, we currently have the tools that will allow us to find its derivative. So f prime of x is going to be the derivative of e to the x minus e to the negative x over 2. And what we'll do is we'll factor out a 1/2 so that we end up with 1/2 times the derivative with respect to x of e to the x minus e to the negative x. Now, I can factor out that 1/2 because I can think of e to the x minus e to the negative x over 2 as 1/2 times e to the x minus e to the negative x. But we must be careful whenever we factor or pull a constant multiple out that whatever we are pulling out is in fact a constant and does not involve the variable. In this case, the variable x. So at this point, we are now ready to find our derivative. So 1/2, f prime of x is 1/2. The derivative of e to the x is simply e to the x minus, and now the derivative for e to the negative x. Now I have to use the chain rule, and the derivative of an exponential function is the exponential function. We leave the argument alone, and then we multiply by the derivative of that argument, in this case the derivative of that exponent. So our f prime of x is equal to 1/2 e to the x. Now my derivative of negative x is -1. So with that in mind, we can rewrite this as e to the x minus e to the negative x times -1. And now I have minus and a factor of -1, so this will turn into addition. So f prime of x is equal to 1/2 e to the x plus e to the negative x. And now I can go ahead and multiply my 1/2 back through. I can think of this e to the x plus e to the negative x as being over 1, in which case f prime of x is e to the x plus e to the negative x over 2, which is the definition for Cosh of x. So we should be convinced at this point that the derivative of sinh is in fact Cosh. And so when I come to find the derivative of the function I was given, f of x is equal to 3 sin of x, then we can go ahead and find f prime of x equal to, using the constant multiple rule, 3 times the derivative of sinh of x. And the derivative of sinh of x is Cosh of x. So the derivative of this function is 3 times Cosh of x. Now let's look at a second example. In this example, our function is tanh of x, and we want to find the derivative. So f prime of x is equal to, now looking at our table here, we can see that the derivative of tanh is sech squared. So when I take my derivative here, I'm going to have sech squared, leave the argument alone, and then multiply by the derivative of that argument. So we have sech squared of 2x times the derivative of 2x. So f prime of x is equal to, now the derivative of 2x is equal to 2. So I'm going to pull that constant up front and write this as 2 sech squared of 2x. And there's our derivative. Now let's look at finding the derivative of e to the cosh of 4x. So we will be using the chain rule to help us find this derivative. Notice that our exponent for our exponential function is more than simply x. So let's go ahead and get started. So f prime of x is going to be, the derivative of an exponential function is e to that power times, and then the derivative of that power. Our argument, or our power in this case, is cosh of 4x. And so we'll go ahead and fill those in. And continuing, f prime of x is equal to e to the cosh of 4x times, now we need the derivative of cosh of 4x. Well, we're going to have to use the chain rule again because we don't have simply cosh of x, we have cosh of 4x. So the derivative of cosh from our table here is sinh of x. So we will have sinh, leave our argument alone, then multiply by the derivative of our argument. So cosh of 4x prime is sinh of 4x times the derivative of 4x. Now, the derivative of 4x, that's going to be 4. So let's go ahead and bring that constant out to the front of the function. So f prime of x is going to be 4 e to the cosh of 4x times sinh of 4x. And there's our derivative. I hope this is helpful.